Get this, even with all the AI hype in 2024, the top open source models for understanding images and text were still kind of lagging behind those big names like GPT-4.
It is true. Yeah, there was a real gap.
The pricing, right?
Between what open source AI can do and the powerhouses everybody was talking about.
But hold on to your hats because NVIDIA's NVLM is changing the game, right? It's like the Robin Hood of AI, taking that cutting edge capability and making it accessible to everyone.
It's exciting stuff.
In this deep dive, we're going to unpack NVLM using their research paper and some benchmarks as our guide. So ready to see what this AI can do?
Absolutely, yeah.
Okay, let's start with the basics. NVLM 1.0.
Right.
What is it? And why is everyone making such a fuss?
So NVLM 1.0 is a family of multimodal large language models, or MLLMs.
MLLMs.
And the key here is multimodal, meaning it can understand and work with both images and text.
So it's like having an AI that can see and read at the same time.
Exactly. Opening up a whole new world of possibilities.
So it's not just looking at a picture and saying, oh, that's a cat.
Yeah.
It's actually understanding the image and any text associated with it.
Exactly. And that's designed to make it excel at tasks.
Okay.
Where you need both visual and textual information.
Gotcha.
Think about describing emotions in a photo or writing code based on a handwritten diagram. That's where NVLM really shines.
Okay. Color me intrigued, but how well does it actually perform?
Right.
The paper mentions benchmarks.
And the benchmarks are where things get really interesting.
Okay.
NVLM 1.0 is not just keeping up with the top proprietary models like GPT-4, it's beating them in certain areas.
Wait, seriously, an open source model is outperforming those big names.
Yeah.
Give me the details.
So let's start with OCR Bench, which tests how well an AI can read text from images.
Okay.
Think optical character recognition.
Okay, so it's like a super reader.
NVLM 1.0 scored higher than every other model tested.
Wow. What about understanding what it's reading?
Right, so that's where VQ-EV2 comes in. That's a visual question answering benchmark.
Okay.
And guess what? NVLM 1.0 aced that too.
Really?
Achieving the highest scores, even outperforming some of the AI heavyweights.
Okay, that's impressive, but let's bring it back down to earth for a second.
Right.
Why should all this matter to, the average person?
Yeah.
What's the big deal?
Here's where the Robin Hood aspect comes in. NVLM is open source, meaning researchers, developers, even you could access and build upon this technology freely.
Oh, wow.
Yeah.
So anyone with the right skills can tinker with this cutting-edge AI.
Exactly.
No need to be a tech giant with tons of resources.
Exactly. It's all about democratizing access to powerful AI, allowing smaller teams and individuals to create innovative applications that might not have been possible before.
Now, the outline mentioned something about different flavors of NVLM.
Right.
What's that all about? Is it like picking a flavor of ice cream?
Not quite. Think of it more like choosing the right tool for the job.
Okay.
NVLM comes in 3 architectures: NVLMD, NVLMX, and NVLMH.
Okay.
Each one is optimized for different types of tasks.
Okay, I'm ready for a taste test. Break down these architectures for me.
So let's start with NVLMD, the decoder-only model.
Okay.
This one excels when you need a deep understanding of the visual details.
Gotcha.
Like in optical character recognition.
Okay.
Imagine it as a meticulous detective, carefully analyzing every clue in an image.
So if I need an AI to read the tiny text on a blurry receipt, NVLMD is my guy.
You got it. It's the detail-oriented one.
All right. What about NVLMX?
That's the cross-attention model.
Okay.
And it's all about speed and efficiency.
Gotcha.
Especially for high-resolution images.
Okay.
Think of it as a sprinter rapidly processing visual information.
So if I need to analyze a massive satellite image quickly, NVLMX is the way to go.
Precisely. It might sacrifice a bit of that.
Okay.
Fine-grained detail understanding.
But it makes up for it with speed.
Got it. Speed versus detail makes sense.
Yeah.
Now, what about the mysterious NVLMH?
NVLMH is the hybrid model, combining the strengths of both D and X.
Gotcha.
It offers a balanced approach, providing detailed understanding where it's needed, while maintaining efficient processing overall.
So it's like the well-rounded athlete of the NVLM family.
Exactly.
A bit of everything.
It's a great starting point if you're not sure which architecture to choose.
Gotcha.
Gives you a good balance of capabilities.
All right, we've got our 3 flavors.
Yeah.
And they all sound pretty impressive.
Yeah.
But let's pop the hood and see what's making this engine run.
Okay.
What's the secret sauce behind NVLM's capabilities?
There are a couple of key ingredients. First, let's talk about how it handles high-resolution images. Instead of trying to process the entire image at once, which would be computationally expensive, it breaks it down into smaller tiles.
Smart. Like dividing a giant puzzle into more manageable pieces.
Exactly. Yeah. And they even have this clever tile tagging system that helps the model understand how those pieces fit together to form the complete picture.
So it's not just seeing random chunks of an image, it's understanding how they relate to each other.
Right.
That's pretty cool. But what about the data it's trained on?
Right.
Does size matter here?
It does, but perhaps not in the way you might think. NVLM's training data is actually smaller than some other models. The focus here is on quality over quantity.
So it's not just gobbling up every image and text it can find.
Right.
It's being fed a carefully curated diet of information.
Exactly. And that diet is a blend of diverse data sets. Covering tasks like image captioning, visual question answering, OCR, and even math reasoning.
Wow. That's a pretty varied menu. So this selective training data is key to NVLM's impressive performance. Absolutely. It's like training an athlete. You wouldn't just feed them anything, right?
Yeah.
You give them a diet specifically designed to help them excel.
I can definitely see the analogy there.
Yeah.
And there's another crucial element. Production-grade multimodality.
Yes.
Okay, you've officially lost me with the jargon. Break that down for me.
It means that NVLM doesn't forget how to be a language model.
Go ahead.
Just because it's learned to work with images.
Okay.
Unlike some other open source models that struggle with text-only tasks, after being trained on images, NVLM keeps its language skills sharp.
So it's not just a one-trick pony.
Yeah.
It can understand both images and text separately and together.
You got it.
Wow.
They achieve this by incorporating a high-quality text-only data set during training.
So it's like cross-training for AI.
Exactly.
Keeping its language muscles in shape.
Yeah, keeping everything sharp.
That's pretty brilliant. So we got this amazing model that can understand images and text in a way we haven't seen before.
Yeah.
And it's open source.
Yeah.
This is huge.
It's very exciting.
But before we get ahead of ourselves, can you give me like a real-world example of what NVLM can actually do? I need something concrete to grasp all this.
All right, picture this. You show NVLM a meme.
A meme.
Not just any meme, though. One that requires understanding both the image and the text to get the humor.
A meme, seriously?
Yes, and the research paper actually has an example.
No way.
Where NVLM successfully explains why a meme about research papers is funny.
Wait, it understands memes?
Yes.
That's amazing. I have to see this.
It really showcases the AI's ability to grasp not just the literal meaning, but the subtle humor and context within an image.
Okay, you got my attention.
Good.
Tell me more about what NVLM can do.
Well, it can also answer complex questions about objects in images, perform math based on information from a table, and even...
Don't leave me hanging. What's the even?
Write code from a handwritten example. Whoa, that's incredible.
It is, right.
Yeah.
These examples highlight NVLM's ability to bridge the gap between the visual and textual worlds in a way we haven't seen before, especially in an open source model.
Okay, I'm officially on board the NVLM hype train.
Right.
This is a game changer.
I agree.
But let's circle back to the open source aspect. What kind of impact could this have on the AI field?
Imagine researchers and developers around the world having free access to this technology. They can modify it, build upon it, and share their findings. It has the potential to unleash a wave of innovation and accessibility. Leading to breakthroughs we can only dream of right now.
It sounds like it could be a defining moment for AI. Kind of like the early days of the internet when everything was open and possibilities seemed endless.
That's a great analogy.
But hold on, with great power comes, the rest.
Right.
Are there any limitations or potential downsides to making such a powerful AI so readily available? That's a crucial point. We have to acknowledge that open access to technology, this requires a responsible approach. We need careful thought and ethical considerations when developing and deploying NVLM to ensure it's used for good.
It's kind of like giving everyone the keys to a high-performance race car. It could lead to amazing things. But you want to make sure everyone knows how to drive it responsibly.
Exactly. It's a powerful tool, and we need to be mindful of its potential impact.
Okay, that makes sense. Before we move on, can you give me a quick recap of the key takeaways so far?
Absolutely, we've learned that.
NVLM is a family of AI models from NVIDIA that can understand both images and text,
Right.
rivaling and sometimes surpassing top proprietary models in benchmarks.
Yes.
It's open source, meaning anyone can use it and build upon it,
Yeah.
potentially democratizing AI development.
Perfect.
Awesome. So where do we go from here?
So we've covered the basics.
Yeah.
But what's fascinating is to dive deeper into how it actually works.
Okay.
For instance, we touched upon those examples of NVLM understanding memes
Right.
and writing code from handwritten notes.
Yeah.
Those are just glimpses of its potential.
There's more.
Yes.
I'm all ears.
If we connect this to the bigger picture,
Okay.
it raises an important question.
Okay.
If NVLM can already do all that,
Yeah.
what's next for this technology?
Right.
What kind of groundbreaking applications might emerge as researchers and developers get their hands on it?
Now that's a question worth pondering, and that's exactly what we'll explore next.
That's what makes this deep dive so exciting. We're not just looking at what NVLM is now, we're trying to envision where it could take us in the future.
All right. You've piqued my curiosity. Let's peel back another layer and look at how NVLM actually works its magic.
Yeah.
We talked about breaking images into tiles.
Mm.
But how does it make sense of what's inside those tiles? It's not like it has eyes, right?
Mm-hmm. Right. It doesn't see the way we do in VLM relies on something called a vision encoder, specifically one called intern VT 6B448PXV15.
Okay. I'm already lost at intern VT.
Haha, no worries. Think of the vision encoder as NVLM's eyes. It takes those image tiled and transforms them into something the language model can understand. It's like translating visual information into a code the language model can read.
So it turns pixels into numbers.
It's more sophisticated than that. The vision encoder analyzes the content of each tile, identifying shapes, colors, textures, even objects. Then it translates all that into a numerical representation that the language model can work with.
That's pretty mind-blowing. So the vision encoder is like a bridge between the visual world and the language model.
Exactly. It's this partnership between the two that makes NVLM so capable.
This whole process is fascinating. But if I'm being honest, I'm still wrapping my head around a language model understanding images. It seems like we're asking it to do something it wasn't built for.
That's a common misconception. Remember, language models, like the one in NVLM, are incredibly powerful. They've been trained on massive amounts of text data, which allows them to learn complex patterns and relationships within language.
Sure. But how does that translate to understanding pictures?
Think about it this way. Language isn't just about words. It's about conveying meaning, understanding context, and even recognizing patterns. Those skills, which language models are great at, apply to images too.
Okay, I see the connection. So the language model isn't just matching words to pictures. It's using its understanding of language to interpret the visual information it gets from the vision encoder.
Precisely. It's like reading a book where the pictures are just as important as the words.
That makes a lot of sense. Now, back to those flavors of NVLM. We know they each have their strengths. But how do you actually choose the right one for a specific task?
It all depends on what you're trying to achieve. For tasks that require a deep understanding of fine visual details, like reading text from a complex image, you'd want to use NVLMD, the decoder-only model.
So anything that needs really careful, detailed analysis of the image.
Exactly. Think of it as the close-up expert.
Okay, I got that one down. What about NVLMX, the cross-attention model? When would you choose that one?
If you're working with large, high-resolution images, say, analyzing a detailed satellite image, NVLMX is the one you want. It's built for speed.
So speed and efficiency are the top priorities for NVLMX.
Right. It might not go into quite as much detail as NVLMD, but it's incredibly fast.
Interesting trade-off.
Mm-hmm.
And finally, NVLMH, the hybrid model. When is that one the best choice?
That one strikes a balance. It looks at the overall context of the image. Think of it like a thumbnail view and processes that through the decoder for deeper understanding. Then it uses the cross-attention model on individual tiles, getting those finer details more efficiently.
So it's like a two-pronged approach, combining the best of both worlds.
Exactly. It offers a good balance of detailed understanding and processing speed. It's often a good starting point if you're not sure which model to choose.
That makes sense. So we've got our different architectures, our vision encoder, and our language model all working together. But there's one last piece of the puzzle. The data NVLM is trained on.
You're right. The training data is like the foundation for this whole AI system. And NVLM's approach to data is really unique.
We talked about quality over quantity, But what does that actually mean in practice? What makes NVLM's training data so special?
It's all about careful selection. Instead of just using any data they can find, the team behind NVLM handpicked and filtered their datasets.
So it's like a custom-designed training plan for an athlete. Only the best ingredients to get peak performance.
That's a great analogy. The training data is a mix of datasets covering various tasks, from image captioning to math reasoning, and each dataset is chosen for its quality and relevance to those tasks.
That makes sense. But wouldn't using more data, even if it's not perfect, make the model even smarter? Wouldn't it be exposed to a wider range of examples that way?
It's a good question. But it's not always about the amount of data. Remember, we're not just training NVLM to recognize patterns, we want it to truly understand. And for that, you need high-quality data that accurately reflects the complexities of language and vision.
So it's like teaching a child.
Yeah.
If you give them a bunch of incorrect or conflicting information, it'll just confuse them.
Exactly. By focusing on quality data, the NVLM team ensures the model learns from the best examples, which leads to better performance and understanding.
Okay, I'm starting to see the value in that. So it's not just about how much data you feed the model. It's about feeding it the right kind of data.
That's a great way to put it. It's like building a library.
Yeah.
You wouldn't just fill it with any random books. You'd want to curate a collection of the most valuable and informative ones.
I like that analogy. It really drives home the point that quality often matters more than quantity.
Exactly. And that's something the NVLM team clearly understood.
This whole data curation thing is really eye-opening. It shows the level of thought and care that went into creating NVLM.
It does.
It's not just about, throwing computing power at a problem. It's about a thoughtful approach to building AI.
Yeah, you're absolutely right. And that brings us back to why NVLM is such a game changer.
Okay.
It's open source nature.
Right. We've talked about it a bit.
Yeah.
But I think it's worth emphasizing, imagine a world where anyone, researchers, developers, even someone just tinkering at home,
Right.
can access and experiment with AI, this powerful keys. It's mind-blowing.
It really is. It has the potential to unlock a level of creativity and innovation that we haven't seen before.
Yeah.
Think about it. Anyone with the right skills could build their own AI-powered applications.
That's an exciting thought. But let's play devil's advocate for a second.
Okay.
Could this also be a bit risky? Putting such powerful AI in anyone's hands?
Yeah.
What about the potential for misuse?
That's a valid concern. With any powerful technology, there's always the risk of misuse.
Right.
We need to think carefully about the ethical implications of making AI this powerful, so widely available.
So it's not just about making the technology open. It's about fostering a culture of responsible AI development and usage.
Exactly. It's about education, collaboration, and setting clear guidelines for how this technology should be used.
Right.
The community needs to work together to ensure that NVLM is used for good.
I see your point.
Yeah.
It's a big responsibility.
Mm.
But let's shift gears for a moment and talk about the implications for the AI field as a whole.
Yeah.
How might NVLM change the game for AI research and development?
It could spark a major shift toward more open and collaborative AI development. Imagine researchers from all over the world building on each other's work, sharing their findings and accelerating progress.
Right.
It could be a massive leap forward.
It's like the scientific community coming together to solve a global challenge.
That's a great analogy.
Huh.
And with the power of NVLM as a foundation, who knows what incredible breakthroughs we might see.
Okay, last question before we wrap up.
Okay.
If NVLM is this big of a deal, what's next? What are you most excited to see happen with this technology?
What excites me most is the potential for unexpected applications. We've talked about memes, code generation, and understanding complex images.
Right.
But now that so many talented people have access to NVLM, I think we'll see a wave of creativity in areas we haven't even thought of yet.
It's like opening a door to a whole new world of possibilities.
Yeah.
And that's what makes NVLM so compelling.
Absolutely.
It's not just a technological marvel. It's a catalyst for human ingenuity.
Well said. It's a testament to what happens when we combine cutting-edge technology with open access and collaboration.
This has been an incredible deep dive into NVLM.
Yeah.
I'm leaving this conversation feeling really optimistic about the future of AI.
Me too. It's an exciting time to be following this field, and NVLM is just the beginning.
To our listeners, keep exploring, keep questioning, and who knows, maybe you'll be the one to unlock the next level of AI innovation.
I wouldn't be surprised at all. That's the beauty of open source. It empowers anyone to become an innovator.
That's all the time we have for today's deep dive into NVLM. Thanks for joining us.
It's been a pleasure. Until next time.